able to view the screen? Is my voice audible?
Yes, sir.
Thank you. So today we'll concentrate on the concept of agent. What do you mean by having an agent which is a rational agent? What do you mean by PEAS descriptors for the agent task environment? How we actually use the agent abstraction in order to understand in a better details the problem that we want to represent as or solve as an AI. Okay. So here at the beginning or at the onset of the lecture, I would like you to understand what we are trying to learn. Okay. So there are certain computation problems we want to apply artificially intelligent solution. Okay, which can be a program or which can be an appliance, a program and a hardware combination. Okay. So to design the solution, we need to understand certain details what the problem is. To certain details we need to understand what the problem is, and agent abstraction is going to provide you that view towards the computational problem. So what we are going to do is we're going to have a computational problem. We want to apply an AI technique to solve that problem. That is, we need to create an AI, artificially intelligent artifact. That artifact can be a program. That artifact can be a hardware-software combination. As far as our syllabus is concerned, we only talk about AI, which are software AIs. That is, they are program or collection of programs or collection of APIs. So for us, when we are dealing with this particular subject this semester, we only concentrate on AI-based software solutions. So that is what a narrower perspective that we will have while we are discussing all these problem settings. Okay, so agent is an abstraction already known by you. Agent abstraction provides us some meaning or some means using which I can represent a real world situation, which is a computational situation, into a representation that will be easily translated into a solution program. Okay, so that is what AI is doing, or that is what not AI, sorry, agent is doing. So agent as an abstraction is letting us design AI based solution. Okay, it's an analysis technique. So अगर आपने software engineering पढ़ा होगा, तो before you actually implement your solution, you do something called as analysis, and then you do something called as design. So analysis and design, these are the two steps that we are trying to understand if we are solving a problem as an AI problem, or if we are designing or if we are actually implementing an AI based solution for certain problems, then how should we go about doing analysis and design? That is exactly what we are learning here. Okay, hope my screen is also shared. Yeah, I have shared my screen. uh, and you're able to see this outline of this chapter. So this is an outline of the second module in the book AIMA, AI for Modern Approach. Okay, although the name is Modern Approach, the book is 22 or 23 years old. So it incorporates the newer technologies as in how you have newer editions. So edition number 3 onwards, you have a lot of new stuff added to the book that includes the deep learning algorithms, that includes certain new approaches in statistical machine learning. But the core part of the book, the starting part of the book, still has at its heart the classical AI, which got developed from these ideas which are called as agent abstraction. Okay, so let us now dwell with this particular idea and understand what do you mean by an agent, which we already know from previous two lectures. I've been talking about this. Okay, let me just clear this there. So what is an agent in general? Before talking about intelligent agent, I should talk about what is an agent. So agent is anything, any entity that can be viewed as perceiving its environment through sensors and acting upon the environment through actuators. So this is the book definition of what do you mean by agent? So please understand the definition is only about what do you mean by agent, and it is not talking about an intelligent agent, this particular thing. Now, as a human, we can know that we have different kinds of sensors and we have different kinds of actuators. So human is also can be thought of as an agent, right? What AI is striving to do is it is striving to replace or mimic. It is trying to do both. Ultimately, it wants to replace, but it is trying to mimic the behavior or thought process of human. So ultimately, if I can consider human as an agent, then the system that I'm developing to replace or mimic it should also be using similar kind of representation. That is why we chose the agent abstraction. Okay. Now the next thing, robotic agent if I have, अगर मेरे पास एक robot है and I want to consider that it to be an agent, then it would have the sensors as cameras, infrared rangefinders. Okay, infrared rangefinders means they are something like a sonar sensors. I just throw the infrared rays, and if there is a blocking element ahead of me, that will reflect those rays, and depending on the time of release of that signal wave and receiving back the signal wave, I can assume or I can predict the distance at which that particular hurdle or that particular thing is. So this is like infrared sensors. So proximity sensors. Maybe there are various kind of sensors. These are just two examples, but even the cameras could also be considered as sensors because they give you a picture of things around you, and based on processing of those pictures, you can figure out if there is certain path to go from one place to the other place. If there is some certain obstacle, then you can decide about an alternative course of action, so on and so forth. So all these are kind of sensors. Then we can consider various kinds of motors as actuators in robotics. So robotic arm आपने देखा होगा, so it has say parts like this. Then every joint there would be certain thing called as motors. So if I have a robotic car, it have a wheel, and the wheel is actually operated through a motor. So this is a axle of the wheel. Okay, at the end of the axle there will be two motors which will rotate and which will give you certain kind of motion. So both are rotating in same direction will give you forward motion. One of them rotating in the reverse direction will give you with a different speed, obviously with a different rotational speed, will give you a certain kind of a tilt or turn, so on and so forth. So there are different ways to provide the actions or actuations based on motors basically, or switches, or maybe something like some hydraulics. Okay, if we are talking about not just small cars, but maybe a hydraulic arm of an excavator, okay, that can be also thought of to have some hydraulic mechanism to be able to move, extend, change the direction, etc. Okay, so these are kind of actuators we talk about in a robotic agent. So agent, when I say, it can be anything. That is what this example says. So agent always works in an environment. So what is the importance of environment in this whole idea of agent abstraction? So agent को तो दो particular type के appendages हमने लगा दिए. One is sensors and the other one is actuators. You'll find this diagram in many books. You have these sensors, you have these actuators, and this is the agents block or agents, what you can say, limit. And there is inside this agent's body or limit, we have something called as this question mark, which is the thought process, which actually gives agent ability to process the percept, sequence, and decide the appropriate action. ये जो दो चीजें हैं, ये कौन करता है? ये क्वेश्चन मार्क वाला ब्लॉक, और ये कितने अच्छी तरीके से करता है, डिपेंडिंग ऑन दैट आई एक्चुअली have different types of agent. How do I achieve this particular thing? That is to process the percept sequence and decide upon the action. This particular thing, how I implement it, depending on that, I have different organizations of or different kinds of agent architectures. Okay, but before going for that, what is this question mark is doing is it is actually mapping percept sequence to the requisite action. Every agent, be it intelligent or be it unintelligent, that is normal agent. So there is nothing like non-intelligent agents. It is intelligent agent or rational agent, and against that a simple agent. So agent will at minimum have percept sequence and actions, और एक क्वेश्चन मार्क एब्सेंट होगा तो भी चलेगा अगर आप किसी को एजेंट कह रहे हो तो. But if we are actually saying that an agent is an intelligent agent, then this question mark will have certain processing element in it, which will make the agent select amongst the action in some predetermined manner. Okay, then that agent would be considered as an agent which is an intelligent agent. Now, when this particular procedure that is actually mapping the percept sequence to the actions is going to select every time an action that is right given all the percepts in the percept sequence, then such agent will be referred to as rational agent. For this to understand, you need to remember the definition of rationality. Rationality क्या होती है? Given the explanation that you have about the scenario, if you are able to take the most appropriate decision that maximizes your reward as an agent, is considered as a rational behavior. So this is the rational behavior example. So I given the description of the entire situation and consequences and the sort of actions that you can do perform, if you are able to select the action which is the most appropriate, that can take you, so what you can say, most close to your goal, is referred to as rational behavior. So if you are choosing that particular action, it's the rational behavior. So if the agent is doing this activity while it is doing this mapping, so this is a mapping, so functional map, this is a functional map. P star means percept sequence. So till date all the percepts are known as assumption hai, and then I'm mapping it to a particular action. Now if every time when I'm doing this mapping or whenever I'm modeling this mapping, so what we do as an agent, we model this mapping. Okay, so what we are modeling this mapping. Okay, and if while modeling this mapping, if I'm choosing the action which is taking me most closer to the goal or most appropriate action that can be thought of or that can be that can be in that particular situation, then I am a rational agent. Okay, so that's the definition of rational agent, and this is how we can describe what is an agent, what is an intelligent agent, and what is a rational agent. Generally in the books, whatever discussion is done is based on rational agent, okay, but they say intelligent agent or they use word intelligent agent. So wherever, whichever book you follow, they will use interchangeably the term intelligent agent and rational agent, because there will be some way in which you will have an implementation of this mapping percept sequence to the actions. Again, depending on this mapping, agent will or agent's actions will be determined. Okay, so agent function or agent functionality can be described as architecture of the agent plus the agent program. Now what is agent program? That is defined over here. Agent program runs on the physical architecture to produce this mapping. So agent program is what? It is some continuous behavior that the agent has in order to show the functions that the agent are, or to realize the function that the agent needs to carry out. So agent functionality is to map the percept sequence to action and to have this in physical presence. जो कुछ organization of components में करता हूँ, that is agent architecture. Okay, and when these components act together and produce this functionality or model this particular functionality, that thing is referred to as an agent program. So agent function is agent architecture plus agent program, combination of both things. Okay, the agent function is something that we realize through the architecture of agent plus the agent program. Okay, so agent program is like say a sequence of steps that agent continuously executes inside it. So it's like a loop or a continuous loop. जैसा event cycle रहता है for any software that is a graphical user interface based software, There's always an event cycle that is running behind the scenes, which will track certain events if they occur. Okay, it will start exploring what to do or what code to execute when the event occurs. It will execute the code, bring out the solution or output, and then it will continue doing this continuously. ये जो event loop होता है, वैसे ही agent का जो program है, it's like a loop structure that is continuously going through certain steps, and these steps are referred to generally as agent program. So this event cycle that agent has, or this program cycle or execution steps that agent has, is agent program. Architecture will provide the support for this loop to execute, and in combination, architecture and the agent program will produce this mapping or this modeling of percept sequence to the agent action. I hope this discussion was there last week or last lecture also done, so you know some details about it now. Okay, now going ahead, this is now we'll talk about certain toy example which people considered as examples that should be discussed in order to understand the concepts that we are developing. So we are developing an abstraction called as agent, and we are saying that this agent will be an intelligent agent if we have certain qualities about that mapping P star map to A. Okay, and those qualities would be the action that this mapping gives me should be the most appropriate action in the given scenario. Then that agent would be rational agent. But in general, when I'm talking about intelligent agent, I will have many alternative ways of modeling this percept sequence to action mapping, which might not always produce me the optimum results or the best results, but it can have certain degree of betterness associated with how I model this mapping. Okay, what I'm saying is, just like human beings, I may not be always a rational agent. I may be sometimes an agent who is intelligent, but who is not always doing exactly what should be right. Right? So it depends on how good this mapping is. We can actually judge the agent to be either just an intelligent agent or a rational agent. ठीक है. Now ये तो हो गया say theoretically understanding the agent abstraction. Now to understand agent abstraction and how good or how bad this agent abstraction is in modeling the real world scenario, we consider some simplistic worldviews. And this simplistic, one example of such simplistic worldview is a vacuum cleaner world. Now, what is this vacuum cleaner world? So, vacuum cleaner world is a world for an agent who is a vacuum cleaner. So, there is an agent called as a vacuum cleaner, okay, whose job is to clean a room out of dust. So, if there is dust in the room, the vacuum cleaner will navigate the room and clear out the dust. So this is the description of this particular vacuum cleaner agent. So vacuum cleaner agent has some sort of mechanism to navigate in the room, locate the dust, suck the dust away, and clean the room. Then this simplistic world also has multiple rooms. In this particular scenario that we are looking at, there are two rooms. They are labeled as A and B. So now vacuum cleaner world that we are looking at is a world with two rooms now. So I can have such description of some real scenario by stripping it down to some simplistic version of a real application. So we see vacuum cleaners everywhere, right? Be it airports, be it railway stations, be it your households. You see different kinds of vacuum cleaners. Big vacuum cleaners are there, handheld vacuum cleaners are there, but we are talking about an autonomous vacuum cleaner which will actually serve the entire room continuously if we are talking about a single room scenario. And whenever some dust gets generated in the room, now or then the vacuum cleaner will understand that there is a dust in the room, and it will be sucking out that dust through the mechanism it has, and it will make